Hello everyone, welcome back to my YouTube channel. Thank you very much for tuning in. Today we are going to be diving into types, right? Last video we started getting a feel of making and declaring variables. This video we're actually going to take a deeper dive into types. Now remember in the first video we were talking about memory, right? Memory allocation, how that works on your machine. Well, there's a reason for that. Every time you declare a variable, what's happening is a bit of space is being set aside. We are writing programs. We're programmers. We're writing programs to solve problems. But if we do not have enough memory to perform said tasks, there's no way for us to efficiently solve this problem because we don't have the memory to perform a certain task or do something. We're taking this down to a very low level. We're just going to talk about how memory works when it comes in terms of variables, right? Once you get that down, you'll be fine. First up, let's talk about how memory is measured, right? Memory is measured in bytes. You might be wondering, how big is that? What the heck is a byte? What are you talking about? Let's think about it this way. A byte is the amount of memory required to store a single character. If you look at your keyboards right now, you see like A, S, D, and W. These are all different keys that you have. A single byte is what we can use to measure the amount of memory, the amount of space, the amount of storage it takes to store one character. And you might be asking, okay, then how is a byte measured? Remember, when we were talking about machine code, these are the zeros and ones that a machine understands. These are the instructions a machine understands. The smallest measurement in memory is a bit, and 8 bits creates 1 byte, okay? So now you can kind of figure out, okay, so we have one character like A is made up of 8 bits. And each character that we have has its own ASCII value, right? So if we have a character like A, it's represented by the ASCII value 65. And how is that represented, right? This is 1 byte. That is 65. How is that represented in bits? That would be 0, 1, 0, 0, 0, 0, 0, 1. Okay? Those are the 8 bits in order. 0, 1, 0, 0, 0, 0, 0, 1. Those are the 8 bits in order to create the ASCII value 65, which evaluates to the character A, right? So that is like, a brief example. These ASCII values, the original, they range from 0 to 127. And then you have and those are like your uppercase characters, your lowercase characters, your null character, like, those like bang, those are 0 to 127, and 128 to 255 are all the additional characters that we have. In the README, I have like a little breakdown of this. I might even put a picture over here actually, so that you can see. I think that would make it a lot easier. And in the README, I actually have a link to a document or webpage that has the entire chart with like all the ASCII values, so you know like what character goes to what ASCII value. I'm not sure if it has a bit, but it's in the README, so you can check the README out. And yeah, that's essentially how we measure memory. So I hope that helped you understand what's going on a little bit more. If not, let me know down in the comments. But this video isn't over yet, so you can hold your horses just a little bit. Now let's try and scale this, right? Because now we know that 8 bits creates 1 byte, and 1 byte can represent 1 character, right? Okay, so now let's look at the specs of this computer. This computer has 16 gigabytes of memory, right? This is the active memory that we can use on our computer at one time. And if we know that the lowest measurement of memory that a computer understands are those zeros and ones, right? Let's think about, okay, after we have a byte, we have a kilobyte. And I'm going to share with you the binary value as well as the decimal value. Quick thing before you go into this, the reason why I'm showing you both the binary and the decimal values is because for the most part back then we were all using the binary values, right? We were saying 1 kilobyte is 1024 bytes, right? But kilo means 1,000. So now we have the decimal values. We'll say like, okay, 1 kilobyte is equivalent to 8,000 bytes. So that's the decimal value, and then we have the, but yeah, essentially, okay, so that's like, you know, your kilobyte, you have your megabytes. Okay, so essentially I'm just talking through the breakdown of the measuring system when it comes to memory. I just thought it would be useful, or more useful, for me to just speed up this entire process and then put the picture from the README of that breakdown on the screen for you. So that is what you see in front of you right now. Feel free to pause the screen and look through it. I'm just trying to keep the video shorter. But yeah, now you understand how this information is measured and stored on our computer. And we can get into, let's revisit variables. Everybody knows you're working for Star Labs. And yes, okay, so let's just do the stuff that we always do. The reason I show this, I got stuff in my head. The reason I show is just so you get a little more familiar with just like what we're writing out every time. And I'm also just gonna use a namespace for the stream. And have our main. Okay, cool. So I'm just gonna declare a whole bunch of different, you know, variables in this, and then you'll be able to see, and then I'm gonna let you know the amount of byte space that is allocated or put aside for the variable in question. Right, the first type we're going to go into is an integer, right? Integer, and this is going to be declared using the keyword int, and we can do int age equals 30, right? And the thing with an integer is that these store whole numbers. These use 4 bytes of memory space. And the numbers that you can store, they range from negative 2,147,483,647 to positive 2,147,483,647. So those are the whole numbers. And like a whole number from that range, any whole number from that range can be stored inside of an integer. The next thing that we have is the floating point. These are also, the keyword for this is just a float. Floating point. Float. These also use 4 bytes of memory space. This is different from integers because it also stores decimal values, or it's meant to store a decimal value at 32-bit precision, right? So like these are about 7 decimal spaces. So we can have a float of pi. You'll also see this in the README. You can make pi, and we know that pi is 3.1415926. I'm gonna stop there, right? So we can just start typing 3.1415926. And these are 1, 2, 3, 4, 5, 6, 7 decimal points, right? So this is like 32-bit precision, which is about 7 decimal points in here, right? So this is the floating point, which is just using the keyword float. We also have double floating point, which is called double. And these are different from both integer and float. It's similar to float in the way that it's storing a floating point. This is twice as precise. Instead of storing values at 32-bit precision, you are able to store values at 64-bit precision, which is like about 14, 15 decimals. Double floating point. And then this is just going to be declared using the keyword double, right? So now that we have a double, we can still use pi, right? And we know that pi is 3.1415265358979, right? So let's start writing that. 0.141592 6 5 3 5 8 9 7 9 9 7 9. Yeah, and now this is a double floating point, so it's twice as precise. This decimal value is twice as precise as its floating point counterpart. Cool. So like these are like numbers that we work with. We also have booleans. Now booleans just store true false value. You can think of your memory, you have zeros and ones, on, off, flipping a switch, right? So this is where we have boolean storing true false values. And the keyword that we use here is called bool. So we can do bool sleepy equals false. Because I got a good 8 hours of sleep last night. My allergies maybe, oh no I didn't get a good 8 hours of sleep. Oh my goodness, I don't know. I had the worst nightmare and I woke up like kind of screaming. It's kind of cool though. Kind of good. We have bool sleepy equals false. This just uses 1 byte. This just uses 1 byte of memory. Next we have character. This is a character, right? And this is what I was saying. We just went into this earlier in the explanation. Characters use 1 byte of memory, which is the equivalent of 8 bits, right? And each character has its own unique ASCII value. But we can do like here. The keyword we use to declare a character is car or char. You can say whatever you want. It's just like how do you pronounce it? Tomato, tomato, potato, potato. But here we have char. We can do middle, initial, and we could do B. Whoops. Middle initial is B, and yeah, that's essentially a character. We also have another data type called void, right? So a void data type means that something has no value. This is normally used when we have a function that doesn't return anything. Like let's say we had a function that we wanted to print, right? Okay, we could make something like that. We can make that right here. A void greet, right? And this is a method that takes in a name and then it just prints out a greeting to that person. So then I would just be cout hello name. Okay, so like this method, this function does not, I know I'm using this function and method interchangeably, which I shouldn't. I believe methods are more when you have a function that belongs to a class. You have a specific method. You have class methods, you have instance methods. And functions are just like, these are functions that you create here. Now this would be more of a function. That's my understanding. That's what I learned. That's what I learned. I could be wrong. Correct me in the comments. I welcome it. Oh, what did I do here?
Congratulations, you played yourself.
But okay, so like here we have a function void greet. It takes in a string called name, and we can print out hello that name. This function doesn't return anything. Its sole purpose is for printing. So that is why we have void as a data type. And the next thing that we'll talk about is string, right? So this is essentially just a collection of characters. And anyway, so we have strings, which is just a collection of characters. And yeah. Here's an example of a string. And we'd just be using string. Full name equals, and then here we can have like a full name. We've been using strings before, right? Remember, we're using the namespace so that we're able to just use string. If we didn't have this, first off, we'll get an error message, right? Or not an error message, these will go underlining. Cout we need the namespace for, string we need the namespace for. Yeah, so if we didn't have this, we'd have to do this whole thing. And then it can understand what this is. But since I started using this namespace in the beginning, I didn't have to worry about that. But here we have full name and Smitty Jugger Man Jensen is gonna be the full name that we have over here. Right, so this is a string with a full name. Cool. I'm gonna stop the recording here. Yeah, this is our video today. That was talking about types. I hope that you enjoyed it. The next thing is going to be more about conditionals and statements like that. It will be a miracle if that gets out tomorrow. I was going to say today, no, but I do not think that's going to come out today. I have to use the next hour to edit these videos and try and upload them as soon as I can. And then I have class. And yeah, that's about it for the video. Thank you very much for viewing. I give you a high five, and I'll see you next time.